Assalamualaikum dan salam sejahtera. Kami daripada kumpulan M yang diwakili oleh Zai Hakimi bin Zailan dan saya Haris Nazmi bin Harun Nizam akan membentangkan mengenai projek kami. Introduction. For application requiring non-standard counting sequence, synchronous abnormal counter utilizing JK flip-flops provide an adaptable solution. Determining the matching JK inputs, defining the desired state transition, streamline the logic, and building the circuit are all steps in the design process. This technique is appropriate for specialized digital system because it guarantees exact control over the behavior of the counter. Step-by-step procedure. In getting the final result, the first step, we need to convert the hexadecimal to the binary numbers. The second step, enter the value of the binary numbers and create a truth table. And the last step was constructing K-map based on the truth table. This was our 7-state sequence. We choose the number 2, 4, 6, 8, A, C, and E for our state sequence. So this is the convert from the hexadecimal to the binary. So we got 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1000, 1010, and 1100, 1110. This is the state of the abnormal counter. For the state 1, abnormal counter was 2. For the state 2, the abnormal counter was 4. For the state 3, the abnormal counter was 6. With the state 4, the abnormal counter was 8. State 5, the abnormal counter was A. State 6, the abnormal counter was C. And the last one, state 7, abnormal counter was E.
My name is Zai Hakimi bin Zailan. I'm the partner of Haris Nazmi. So I will be continue this part and so on. This is the citation table which contain the Q output and the input J and K. To find the J and K, we need to use the present state and the next state for each output that been provided. So here, the present state is 0 and the next state is 0. So the input J and K should be 0 on J and X on K. Meanwhile, when present state 0 and next state 1, it will be 1 on J and X on K. On the other hand, if the present state is 1 and the next state is 0, J input would be X, meanwhile K being 1. Lastly, if both present state and next states are 1, so the input J and K should be X and 0. So this is the truth table that me and my team have been constructing to produce the circuit. So here we have the Qn, which is the current state or the present state, and Qn plus 1 is the next state. It's gonna be 4 individual output, so Q1, Q2, Q3, and Q4. Therefore, the output JK also will be J1K1, J2K2, J3K3, and J4K4. So our truth table is looking like this. When the Qn is 0010, the next state is 0100, then our output will be on JK1 will be 0x, JK2 1x, JK3 x1, and JK4 00. when the Qn is 0, 1, 0, 0, and the Qn plus 1 is 0, 1, 1, 0. JK1 will be 0x, JK2 will be x0, JK3 will be 1x, and JK4 is 0x. On the third line, for the Qn is 0, 1, 1, 0, and Qn plus 1 is 1, 0, 0, 0. So the JK1 will be 1x, JK2 x1, JK3 x1, and JK4 0x. On the fourth line, when Qn is 1, 0, 0, 0, and Qn plus 1 is 1, 0, 1, 0, JK1 will be x0, JK2 0x, JK3 1x, and JK4 0x. On line 5, Qn is 1, 0, 1, 0, Qn plus 1 is 1, 1, 0, 0. The output JK will be JK1 x0, JK2 1x, JK3 x1, and JK4 0x. On the sixth state, Qn will be 1, 1, 0, 0, Qn plus 1 will be 1, 1, 1, 0, and the output JK for JK1 will be x0, JK2 will be x0, JK3 1x, and JK4 0x. For our final state, on Qn will be 1, 1, 1, 0, Qn plus 1 will be 0, 0, 1, 0. So the output JK on JK1 will be x1, JK2 x1, JK3 x0, and JK4 0x. So this is the K-map for the JK flip-flop that will be used to construct our board. Our input for K1 and J1 will be the same, which is Q2 and Q3. For our J2 and Q2, also having the same input, which is Q1. The input of J3 will be equivalent to 1, while K3 is Q3 bar or Q4 bar. And this is our J4 and K4. The input for J4 and K4 is the same, which is 0. Now we go to simulation circuit in multisim. This is the circuit that me and my team have been crafting. So now let's go to the demonstration of how this circuit works. So this is our simulation on multisim of the circuit that we've been crafting. So by pressing the play button, the clock will automatically switch the 7 segment into the desired sequences, which will be 2, 4, 6, 8, A, C, and E. So thank you very much for watching this video.